6.3 The nature of energy. Another mystery in the early 20th century involved the emission spectra observed from energy emitted by atoms and molecules. For atoms and molecules, one does not observe a continuous spectrum as one gets from a white light source. Here in the picture, we have a white light source that is emitting a continuous spectrum, and you can see the rainbow pictured. Only a line spectrum of discrete wavelengths is observed. Here you see the emission spectrum for sodium and hydrogen. We also know that atomic emission spectra are unique for each element, and we say that they provide a unique fingerprint that helps to identify the element present. Niels Bohr adopted Planck's assumption and explained these phenomena in this way. 1. Electrons in an atom can only occupy certain orbits corresponding to certain energies. 2. Electrons in permitted orbits have specific allowed energies. These energies will not be radiated from the atom. 3. Energy is only absorbed or emitted in such a way as to move an electron from one allowed energy state to another. The energy is defined by this equation. The energy absorbed or emitted from the process of electron promotion or demotion can be calculated by the following equation, where R sub h is the Rydberg constant, 2.18 times 10 to the negative 18th joules, and Ni and Nf are the initial and final energy levels of the electron. Sample exercise 6.4, electronic transitions in the hydrogen atom. Using figure 6.14, predict which of the following electronic transitions produces the spectral line having the longest wavelength, N2 to N1, N1, N3 to N2, or N4 to N3. The wavelength increases as frequency decreases. Hence, the longest wavelength will be associated with the lowest frequency. According to Planck's equation, E equals h nu, the lowest frequency is associated with the lowest energy. In this figure, the shortest vertical line represents the smallest energy change. Thus, the N4 to N3 transition produces the longest wavelength, lowest frequency line. Practice exercise. Indicate whether each of the following electronic transitions emits energy or requires the absorption of energy. The transition from N3 to N1, N2 to N4.